Hi, let us see what is hydrostatic equation of this video. Hydrostatic equation is one of the basic equation that you must know. Let us see why you must know the hydrostatic equation and its uses. Hydrostatic equation is mainly used to calculate the variations of pressure and density with a change in altitude. Now let us see the derivation of the hydrostatic equation. Now let us consider an atmosphere which contains a small stationary element in it which has the bottom phase and the top phase which is slightly higher at a distance of dH. This dH is the small stationary element in the atmosphere. Now consider at the bottom phase the pressure P is felt, which gives rise to the upward force, which is F is equal to P into A, where P is the pressure at the bottom phase into area, which is 1 into 1. So the force which is felt at the bottom phase is equal to P, which is the upward force. And similarly, the force on the top phase, which is slightly higher in the altitude by a distance of dh. Since the pressure varies with the altitude, the pressure on the top phase is slightly different by a small value dp. Hence, in the top phase, the pressure P plus dp is felt. It gives rise to the downward force. So the force on the top phase is F is equal to P plus dp, which is the pressure at the top phase into area 1 into 1, which gives the force F is equal to P plus dp, which is the downward acting force. Similarly, the volume of the stationary element is B is equal to dH into 1 into 1, which gives volume is equal to dH. And the density of the stationary element is rho is equal to mass by volume, where the volume is dH. Substituting it in volume, we get mass is equal to rho dH. Since we are considering it as an atmosphere, we have to take gravity also into account. So we are converting mass is equal to weight by gravity, which gives the same equation. Substituting in this equation, we get weight is equal to gravity rho dh. So this is also, since the gravity is acting also in the downward, it is a downward force. Now equating the downward force and the upward force, we get this stationary element. So we are equating this upward force and the downward force, where P is the upward force and P plus dp and rho dh is the downward acting forces. Downward forces. By equating these two, we get the stationary element. Now, cancelling P and P, we get dP is equal to minus rho gdh, where the negative sign indicates the downward acting force. Since this equation clearly says that the pressure varies with the change in altitude. So this is the hydrostatic equation. Now let us see one problem related to the hydrostatic equation. Consider an unmanned aerial vehicle is flying at an altitude of 100 meters. Now, determine the pressure at that altitude. So, to determine the pressure at that altitude, we can use this hydrostatic equation. By integrating this equation, we can see that P1 to P2 dP is equal to minus rho g. We are considering this rho g as constant in this scenario because at this altitude, the slight changes in rho g won't make much difference in the solution. So we are considering this rho g as constant in this scenario. So I'm integrating this dh h1 to h2 dh. By integration, we get that P2 minus P1 is equal to minus rho g h2 minus h1. By substituting the respective values in this equation, we get P2 minus the pressure at the sea level. We know that 101,325 pascals is equal to minus the density at sea level is 1.225 kilogram per meter cube into gravity is 9.81, and we know that H2 is 100 meters minus at sea level is 0. By solving this, we get that P2 minus 101,325 is equal to minus 1201.725. By bringing this value to here, we get that P2 is equal to 100,123 pascals or 1.00123 into 10 to the power 5 pascals. So we got the value that at 100 meters the pressure is 100,123 pascal. So from this equation we prove that the pressure varies with the altitude. So the pressure from this values we can see that the pressure at sea level is 101,325 is greater than the pressure at 100 meters 123 Pascal. So from the solution we can say that the pressure decreases with the increasing in altitude. So hope you understood what is hydrostatic equation in this video.